This video is for the lesson 4.6 homework. So today what we're doing is we are looking at the key features of quadratics, okay? So quadratics, they open up like this or they open down like this, okay? And it's a parabola. That's what the shape is called. Linear equations make a line. Quadratic equations make a parabola. Another key feature are the minimum and maximum values. And these are also the vertex is what that point is called. So if it opens upward, it's a minimum value. If it opens down, it's a maximum value. Okay? The other thing, and I don't know if y'all realize that or realize this, when you graph a quadratic, actually, wait, cancel. Let me open up a graph here. When you graph a quadratic, where this graph crosses the x-axis here and here, the x-intercepts, those are the solutions. Those two answers that you found today, that's these 2 points where it crosses here and here. So the x-intercepts of a quadratic are also the solutions, the answers. So your options for quadratics, you can have two x-intercepts, so two solutions. You can have, let's see if I can get this thing to kind of shift and pull again. You can have one x-intercept where it just kind of barely comes up and grazes the x, it just touches it in one spot. Or, like you saw today, you can have one solution or no solutions, and that's where it never touches the x-axis. There's no x-intercepts, okay? Those are just the basic pieces, honestly, that you should already know about quadratics, but I wanted to cover them because it makes this stuff easier. Okay, so vocabulary. What's the name of the vertex of a graph of a quadratic that opens downward? So this is opens downward, and it's called a maximum. Where these points come in is what you're going to do on Monday with domain and range, because whereas the domain of a graph like this is all real numbers, I can plug any x in there. The range would be from the maximum point and down. So all numbers less than that y value. Okay? If it opens up like this, then your y, your range is going to be all values greater than that point. So quadratics are a little bit different when it comes to domain and range. Number two, what is the name of the vertex of the graph of a quadratic function that opens upward? That's the minimum. So a max and a min. And your calculator will find the max and the min for you. All right, so this year, this class, we deal with data given to us in tables, okay? Typically, so when I teach this lesson in Algebra 1, they give us the function, they give us the equation already written out, and then we find the key features. This class is about data and tables, so they give us the table, and then we have to write the function and then find the key features. So these tables are pretty straightforward when it comes to finding the function, writing the function. The first, if you can identify the vertex, okay? So what you do is you look at the y values, okay? What you're looking for is a minimum or a maximum point. Do we have that in this table?
Yes.
What is it? No, the y's. Do we have one number that stands out as smaller than the rest or bigger than the rest? -4, right? From this point, all the values increase. Now, you can actually take a table of data and turn it into a graph using your calculator, okay? If you go to the list in the spreadsheets, and this is how we did linear regression, but you can use the same idea and type your table in. Okay? And then what you do, now I gotta think my way through this, is doc, insert, and then it's data and statistics. It will take that table and it turns it into a graph. What you have to do, I know it looks messy, and why we type that X and the Y at the top of the table, you can click down here and change this to the X-axis, and then you can click over here and change this to a Y-axis, and it accurately graphs my data. And from here I can look and I can go, oh look, that's my vertex. If you have a vertex, you can write an equation for this. I'm going to show you an easier way than this, okay? So my vertex here is 4, -4. All right, so using a vertex, and in a vertex we label as H and K, okay? I need one other point. I always tell kids when we're looking for points to build an equation, try to avoid zeros if you can. So I'm going to use this one, 3 and -3. 3 and -3. That's going to be my X and Y. They actually give this to the students on the Algebra EOC. They give this vertex form to them. And that's what I can use to write this quadratic function. So vertex form is f of x equals a x minus h squared plus k. What I can use this for is to find my a value first, and then I can use that to find the whole equation. So it's plug and chug at this point. Remember, f of x is just a fancy y. So instead of f of x, I'm going to write a -3. A is the value that I'm looking for, so I'm going to leave that. X is a 3. H is a 4. K is a -4, so I'm going to do -4. And then I can start breaking this thing down. So 3 minus 4, well, that's -1. No, you can't put this one into InSolve. InSolve doesn't do quadratics. So just break it down piece by piece. PEMDAS, parentheses first. 3 minus 4 is -1. Okay? So -3 equals A. So now this is -1 squared minus 4. PEMDAS, so we did parentheses. Now we're going to do exponents. -1 squared is just a +1. So I can rewrite that. Does anything change? Does anything happen when we multiply by 1? No. So I can just turn that. I don't have to write 1a. I can write just an a. And now I've got an equation I can solve. Now this I can InSolve. So I'm going to add 4 to both sides. -3 plus 4 is a +1. And that's my a value. All of that just to do it again. Now what I'm going to do is I'm going to leave this as f of x and x, but I'm going to use this 1 where the a is. Still going to put my h value in, still going to put my k value in. And then I can simplify this into standard form. So I have to do this piece first. So x minus 4 squared looks like this. And this is FOIL. So first, x times x is x squared. Outside, x times -4 is -4x. Inside, -4 times x is -4x. Last, -4, -4, +16. Combine like terms. And all I did with all of that, is I got rid of that exponent. So here's what I'm sitting at now. 1 times anything doesn't change. So here's, after it's simplified, what it looks like. All I did was expand that. 1 times something doesn't change it, so I can rewrite it as x squared minus 8x plus 16 minus 4. Combine like terms. So x squared minus 8x plus 12. That is how you write a quadratic by hand. I teach that to freshmen, okay? So I am going to teach you an easier way. F of x equals x squared minus 8x plus 12. All right, restricted domain and range. So just the domain and range from the table. So remember, domain is x. So X is a member of the set. So I'm going to look up here. What's my smallest X? So 2 is less than or equal to X is less than or equal to. And then what's my greatest X? 6. Okay. And then I do the same thing for the range. Y is a member of the set. What's my smallest Y value? -4 less than or equal to Y less than or equal to. And then my greatest is a 0. So remember, restricted domain and range is talking about just the values in the table. Sometimes, and on Mondays they'll say that, write the domain of just the table. And that's when you would write it in the list in 2, 3, 4, 5, 6. If it's telling you to write it of the function, so this is the restricted domain and range of the whole function, that's using the data in the table, but still taking into account the values in between. So there's a lot of different ways that this can be worded. All right, X-Intercepts. Once I have this, my calculator will do the rest of the work for me. Okay, so I'm going to start fresh here with a graph, and I'm going to type this function in. X squared minus 8x plus 12. Okay? The X-intercepts, and this is what we were talking about, these are also the solutions. You could plug this into the quadratic formula, but you've been given a gift of the calculator. In the calculator, the X-intercepts are called the zeros. And so menu 6, 1 will find the zeros. And you get these little boundary lines. You want to set those boundaries around the X-intercepts, and you have to do them separately. So I set it just to the left, and then I kind of scroll over, and you can see the word 0 pop up. That means I captured it. It caught the 0. And then I click again, and it literally puts the value up on my screen. So that's 1. Then I got to do the other one. Menu 6, 1. To the left and to the right, and then there's my other X-intercept. And so I can write those. I can write them as ordered pairs, or I can write them as solutions. How I teach algebra kids, if it says X-intercept, you write it like an ordered pair. If it says 0, you write it like this. And that's typically what they want. And then finally it says identify the vertex of the function and determine if it's a max or a min. So looking at my graph, do I have a maximum or a minimum? I have a minimum. This is another thing that your calculator will do for you. So I can do menu and then 6 again, and then 2 or 3 are your min and your max. So I want a minimum, set it to the left and the right, and it literally puts the point up there for me. 4, -4. All right, I do want to show you an easier way. I've got time to do it too. Am I good to move? Do I have anybody still writing? We okay? All right. If we have a nice pretty table, which we will not in this unit, but in this case we do it on Monday on the quiz, you will. You can do quadratic regression. Okay? So, just like we did with linear regression. And then we type our values in. Okay, and then menu 4, 1. 3 was linear regression, but if you look down here at 6, so menu 4, 1, 6 is quadratic regression. Change them to X and Y's. And then it gives you the A, the B, and the C. So f of x equals, if A is 1, I just write x squared. If B is -4, -4, and the x goes behind the B, and then C is an 8, plus 8. Way easier than doing it by hand, right?
So is the K and the C basically